So at this point, we have factored GCFs out. We have factored by grouping. We have factored trinomials when the leading coefficient was 1. We like those. And then we have factored trinomials when the leading coefficient was not 1, which were much more difficult. Now we're going to factor binomials. Now, before we factor some binomials, let's remind ourselves of a property that we saw earlier. That is that if you have a plus b times a minus b, oh, hold on one second. There we go. That will be equal to a squared minus ab plus ab minus b squared. The middle terms will disappear because they are the opposites of each other, right? So if you have minus ab and a plus ab, that's all going to go away. As soon as I find the little slash thing for it, there it is. And that leaves you with a squared minus b squared. Awesome. So this is how the difference of squares works. So if you take a binomial and you multiply it by its conjugate, then you're going to end up with firsts and lasts. The outers and inners will end up canceling. And we saw that happen in the FOIL section, which was 6.2. Now we're going to use that property to help ourselves because we're going to go backwards. So in 6.2, we started with a plus b, a minus b, and we would FOIL it out, right? Now, because we're factoring, we're going to go backwards. As we're going to say a squared minus b squared, that must be equal to a minus b, a plus b. They must be conjugates of each other. Identical except for one's a plus in the middle and one's a minus in the middle. That's how this is going to work. All right, so let's do it. Now the good thing about these is when you spot them, they're kind of obvious because they're binomial, right? So you're looking to see, hey, is this a binomial that has something squared minus something else squared? If it does, it's going to follow this pattern. Okay, so sure enough, n squared minus 36 is what we've got. Okay, that must be two parentheses. You think, what squared makes n squared? Well, that's easy. That's n and n. And now you need to put a plus in one of them and a minus in the other one. And then you need to think, okay, what number could I put in here in both spots that would multiply and get me 36? Well, it's got to be the same number because otherwise the outers and inners won't cancel like we need it to be. So that would be plus 6 and minus 6. It's the easiest factoring you can get, right? Simple as pie. When you see a difference of squares, it's got to be equal to the sum and then the difference, right? They're conjugates. N plus 6 and n minus 6. Now, the only question you might be wondering is to yourself is, where did I come up with the 6? Well, a squared is equal to n squared. That means that a is equal to n. So, I mean, you just substitute in the formula. And then for the other one, b squared is equal to 36, but luckily for me, we've spent a whole chapter solving stuff like that, right? So you can say, oh, okay, b squared is equal to 36. That must mean that b is equal to the square root of 36, which is 6. We learned that stuff in chapter 4, as a matter of fact, with the rational powers. We would say it was 36 to the 1/2 power, but it accomplishes the same idea, right? So you could say the square root of 36, you could say 36 to the 1/2. That's what we did in chapter 4. So either one of those works. No, you don't actually have to show all of that work when you're normally doing it. I'm just putting it in here so you can see how it follows the pattern that's in the table above. So it's following this difference of squares pattern. But I'm actually working hard to give it some work here because these are so simple. All right, so let's look at the next one. 16x squared, take away 9y squared. Oops, except that's not going to work. There we go, minus 9y squared. Okay, so it's going to be two parentheses. Now you need to take the square root of 16 because you need a number that when you multiply it by itself will get you 16. That's 4. So 4x and 4x, one's going to have a minus, one's going to have a plus. That's how you're going to get negative 9 here. Now, you could try 1 and 9, but that won't do you any good because you won't get outers and inners to disappear like you need them to. Instead, you want to use 3y. So 3y, 3y. And there you go. Done. All right, now those are the easy ones. Let's get to a little bit harder. We're going to kick it up a notch by putting a whole bunch more powers in there. So we have 4m to the 6th minus 49m to the 10th. Okay, so what I noticed right away is I've got m to the 6th in both of these as a GCF. So I'm going to take that out, and that leaves me 4m to the 4th. Ooh, yeah, 4m to the 4th. Take away 49m to the... Oh, I'm being silly. This is the m to the 4th. There we go. 4 minus 49m to the 4th. Ta-da. Okay, so we can still do this, right? We're going to have to think m to the 6th, leave that in front. And now I need double parentheses because it's difference. It's a binomial and it's a difference of squares. So you got to think, okay, what squared would make 4? Well, that's obvious. That's 2 and 2. One will have a plus, one will have a minus. Fine. And then I think it's kind of obvious what the numbers are. It's got to be 7 and 7. Then the question is, how do you get the m to the 4th power like you want? Well, you got to break it up evenly. So you got to do m squared on this one and m squared on this one. Anything other than that and the outers and inners wouldn't cancel. Now remember, as always with these problems, you should be able to multiply and get back what you had. 2 times 2 is 4. Outers is minus 14m squared. Inners is plus 14m squared. Disappears. Last is minus 7 times 7, which is 49. M squared times m squared is m to the 4th because you add those powers. So sure enough, it works. All right, last one. X to the 4th, take away 81. All right, so this is a difference of two terms, and it's binomial again, so that's going to be a sign. So it's going to be x squared minus 9 and x squared plus 9. Now you think you'd be done, right? You said, okay, look, x squared times x squared makes x to the 4th. 9 times 9 makes 81, right? One's a minus, one's a plus. That's how outers and inners all disappears. Oh, but you are not done at all, and that's because of this part right here. See, x squared minus 9 is a difference of squares in and of itself. So you've got to figure out what that part is on its own and then write the rest of it. So x minus 3 times x plus 3, because 3 times 3 makes 9. One's a minus, one's a plus. That's how you have no middle term here. Now, it's not going to work on x squared plus 9. So what students always want to do is they want to say, oh, x squared plus 9, that must be x plus 3, x plus 3. But take a moment and think about that. First would be x squared, cool. Last would be 9, great. But what's outers and inners? Outers is 3x and inners is 3x. That makes 6x. But there is no 6x here. So that's not going to work. Right? To which I say, well, what actually happens is that it's prime. X squared plus a 9 or plus a 16 or plus any difference or any square is prime. So that's like a note. Note. A squared plus b squared is prime. There we go. You made a note to yourself? All right, done with that. Let's stop here on this video and I'll come back to do the next one, which is the difference in sum of cubes. See you then.